Today's gate question is, what is the electric flux integral E bar dot dA through a quarter cylinder of height h due to an infinitely long line charge along the axis of the cylinder with a charge density of Q. Okay. See here, this is the quarter cylinder of height h. Okay. Now, at the center of the cylinder, you have infinitely long line charge. Then you have to find the electric flux through this cylinder. Okay. So, actually, initially what is there? See here. Cylinder. This is a cylinder. Okay. And this is the axis of the cylinder. Okay. If you assume a charge, line charge, this is the line charge. Line charge, rho L. Then to find electric field at the surface of the cylinder at any point, at this point E bar. And if this distance is rho, the radius of the cylinder, then this E bar is equal to rho L by 2 pi epsilon naught rho A rho. Yes, this is the cylinder of radius rho. Assuming that along the axis of the cylinder we have infinitely line charge rho L, infinitely line charge rho L. And if you want to find the electric field distance at any point on the surface of the cylinder, it may be here or it may be here, whatever it may be. The E bar is given by rho L by 2 pi epsilon naught rho A rho. So this is the direction, A rho is the direction. You know, the cylindrical coordinates are P of rho comma phi comma z. This rho specifies this radius direction, phi angle, z length. Okay. So now using this concept, you can find the electric flux integral E bar dot dA. Okay. So what is our problem? The same cylinder is cut at center first. It becomes half cylinder. Again in that half cylinder, quarter cylinder is removed. So you'll get, see here, suppose this is your half, and yes, if you remove another half, then you'll get only this one. So that is called quarter cylinder. The other things are common. Yes, this is your quarter cylinder. The remaining part gives you the full cylinder. Yes, if you complete this, totally if you complete this, you're going to get full cylinder. This is the axis. This is the axis of the cylinder, like this. And here, the axis, along the axis, we have a charge, line charge, infinitely long line charge of charge Q. The cylinder height is h. Okay. Then they ask to find electric flux. Is integral E bar dot dA is how much? So now what is E bar here? Yes, just use this to write the E bar for this given concept. So rho L, here is the rho L and here is the same thing, charge Q, 2 pi epsilon naught. Yes, rho is the radius, this is the radius. Rho is the radius and the direction is A rho. Therefore, integral E bar dot dA is equal to, dA is differential area, okay, So now as E bar is in arrow direction, in arrow direction the dA is equal to rho d phi dz. Rho d phi dz, that is the area, differential area in the direction of arrow. So totally, yes, as dA is rho d phi dz and this is the differential area, totally the integrations are 2. Then just substitute E bar q by 2 pi epsilon naught rho arrow dot dA is rho d phi dz in the direction arrow. So you have to substitute, you have to write arrow also here. So now rho gets cancelled. Write q by 4 pi epsilon naught here. Arrow dot arrow is 1. So you'll be with only d phi dz. What are the limits now? What are the limits of phi? As the cylinder is quarter cylinder, actually if the cylinder is full, the phi is 360. Okay. For the half cylinder it is 180. For the quarter wave cylinder it is pi by 2, means 90. So integral 0 to pi by 2. And what are the limits of z? Z limits? Yes, z limits like this you have to take. This is the axis z axis. What is the height? H. So 0 to h. Okay. So q by 4 pi epsilon naught. For phi it is integral d phi. Phi between the limits pi by 2 and 0. So you'll get pi by 2. Next, again integral 0 to h 1 dz. So z between the limits h to 0. So you'll get h. So it is q by 2 pi epsilon naught. Okay. So totally what is this? It is q by 2 pi epsilon naught. Okay. So totally what is this? It gets cancelled. It is hq by 4 epsilon naught. Answer. So this is integral E bar dot dA, the electric flux integral E bar dot dA. Okay. So the option D, hq by 4 epsilon naught, hq by 4 epsilon naught is the correct answer.